2.1, numbers 13, 14, and 15. All right, so number 13 has a particular function, which is f of x equals 1 on x. And there's a particular point P, -1, -1, at which we would like to find the slope of this function. Okay? So let's just write that very quickly. What we're doing is finding slope of the curve. Oops. Slope of the curve 1 on x. Slope of curve f of x equals 1 on x at P. Okay, and we're going to do this using a limiting process. I want to draw a picture of what this means first before I do the calculation. It's not necessary for the problem, but again, just to give a visual idea of what's really happening as these calculations proceed. Because the numbers in the table are so small, that is, they have small differentials, meaning they're very close to 1, 1.05, 1.01, 1.005, and 1.001. Those small differentials of 0.05, 0.01, 0.005, and 0.001 are going to mean I'll have to exaggerate the graph to accentuate what is going on, probably. So the function 1 on x, we know as a vertical asymptote. This is a parent function that you learn about in pre-calc usually. So there's our backdrop to this curve. And if I put a -1 here and a -1 here, so that point is on the graph. So too is 1, 1. It's true over here, 1, 1. But we're not really concerned with the right-hand side of this graph. I'll draw it anyway. So it looks something like this. On the other side is very similar. So maybe something like that. And what we're trying to get a handle on is the slope right here of that tangent line. That's what this process we're about to go through should reveal to us, or at least give us a good idea of what it is. We'll have better methods in the next few sections. All right, so slope of the red tangent line, okay, is the goal of this process. And the slope of that tangent line is the same as the slope of the curve. Again, that's by definition. Okay. All right, so when we select, I'll do 2 of these. I'll do -1.05 maybe, and the last one -1.001 in just a moment. So taking the first one, -1.05. If this is -1, again, I'm going to now exaggerate, and I'm going to say it's really way over here, this -1.05. Of course, that would not be appropriate to scale, but just to get an idea what's going on. So that means I'm on the curve here at this point. And we would have then a secant drawn between the point P under discussion here, right? P is -1, 1, and this other location further away. Right. I'm just going to leave it there. I don't want to draw through to the other side because it's going to look too messy in a moment. So there is a secant line. Okay. So there's at -1.05. Drawn between that point and this point, we will have a slope of this secant. The slope of the secant is not the slope of the red line. It is not as steep, you might say, as the red line yet. As we move closer, what's going to happen next And I'm going to take the first value of negative 1.05 and then negative 1.001. It's extremely close. I'm going to still draw it further away just for exaggeration purposes. Let's just pretend it's here, negative 1.001. Again, not to scale at all. So then there's a point associated with that on the curve, around there maybe. I could draw another secant line. Between the point P and that one. Okay, they're getting a little obscured here, but hopefully you can see that. Okay, and certainly that line has a slope which is closer to being like the red tangent line. Okay, and as we take the values closer and closer, right, as this point moves down the curve towards P, the slopes of all the secant lines which would be constructed between P and those points, well, all their slopes will get in closer and closer to the slope of the red line, and the limiting process should reveal what exactly is the slope of the red line at P, i.e. the slope of the curve there.